Hello everyone. I welcome you all to this 30 days masterclass series on electric vehicle design using MATLAB Simulink. Today is day 19. Today we are going to discuss about Simscape introduction section. I welcome you once again everyone here. First I would like to confirm my audio. So actually now I'm in native. So here a little bit internet and then lighting issue will be there. So can you please confirm my audio? Am I audible? Am I audible? Can you please confirm? Very good evening, Tiwari, Lok, Maya. Very good evening. Can you please confirm my audio? Audio. Whether am I audible? Yeah. Thank you, Tushar. Thank you. Doing good. Happy Ganesh Chaturthi. Yes. Thank you, Karthik. Thank you. Thank you, participants. Thanks for your comment. Yes. So let's move to the topic. Yeah. Thank you. So about the Pantech, Pantech is an educational equipments manufacturing company, and from Pantech you can get lab equipments for EEE, ECE, computer science, IT, AI, robotics related products. You can get it, and our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about these things, 1.5 lakh students, and forthcoming months we have again scheduled few more free masterclass series. So if you are interested, so please keep engaged with the entire class also. So now we are going to discuss about Simscape. What is the Simscape? What are all the multi-domain systems? How we can integrate all these things under. So please keep engaged with the entire class. Yes. So if you have any questions on the previous class, please share here so that I can try to give you the answers. Yes. Thank you, Gopalan. I will reply you after this slide. Latest SOC calculation technique. See, actually, latest SOC, that is machine learning based, yes, support vector machine or SVM method. So please check in this. Actually, this is, series I have not scheduled the topic. Yes, thank you. In the internship only, you can get all 30 days class. Yeah, thank you, Gautam. So if you have any questions in the previous class, so please, no questions. Great, Indrajit. Thank you, Krishna. I will respond you after this live. Yeah, Mr. Mani, please check till day 16 we have uploaded. Please check till day 16 we have uploaded. Due to very poor light, my screen has been disabled. So let us check one by one. Yes. So these are all the content we are going to discuss in this session. So keep engaged with the entire class. So what is Simulink and then what is Simscape? Simulink is a block diagram based on the Kirchhoff voltage law, and then again, so this is it will take only the equivalent circuit values. So it won't consider the practical values. Like the practical values, nothing but if you take a mass. So let us take that is a mass will act as a capacitive equivalent to the capacitive value. So in that case, we won't bother about the tolerances of the capacitance in the Simulink diagram. Whereas in the Simscape, we will take into that property also into our account, like the tolerance. So what do you mean by tolerance? Do you have any idea about the tolerance? Do you have any idea about the tolerance? Can you please comment? What do you mean by tolerance? So how you can work in very close to the hardware topics. Can you please comment about the tolerance of the components? Yeah, I'm waiting for a reply. I'm waiting for your reply. So can you please comment about the tolerance? Permissible value. Great. Tolerance is the percentage of error. Yes, exactly. Yes, thank you, participant. See here, the tolerance value of the component will be taken care into the Simscape domain, Simscape method. Whereas in the Simulink, we won't bother about those properties. So that's why we are claiming that Simscape, if you are developing an application program in the Simscape, then that will be more closer to the hardware or system level simulations, right? So that's why we are going to concentrate on more on this topic. So now, so what is Simscape? So here in the Simscape, you can model your component with multi-domain physical systems. So what are all the multi-domain physical systems? So do you have any idea about that? So what are all the multi-domain? So can you comment about the multi-domain? Can you comment about the multi-domain? What is multi-domain physical systems? Flexibility. Okay. See, actually, according to the engineering stream, so you can get multi-domain. You can classify the domains by electrical systems, mechanical systems, and fluid systems, and then thermal systems. So these are all these are all the multi-domain systems. Actually, physical domain systems, right? So here we can incorporate all these components into the model, into the simulation systems. So in that case, we can get very close to these. Yes, Mr. Praveen. Yes, Rahul. Mechanical, electronics, electrical, and thermal, fluid. So these are all the multi-domain systems. And similarly, you can manage the integer values. Excuse me. You can manage the data types, as well as you can store the data, you can extract the data from the simulation systems, right? So these are all the major biggest advantages in the Simscape development platform. And here, so this is the multi-domain system. So first one is a mechanical, electrical, hydraulic or pneumatic, and then thermal. So let us call it as a fluid, right? So these are all the multi-domain system, four domain systems. So we can integrate any all these components into the physical Simulink systems. Whereas in the sim power system, we cannot integrate all these things. So there we can take only the equivalent circuits. All right. So here, that is the very biggest advantages of the Simscape domain. So now let us check what are all the mechanical systems, and then how we can integrate to the Simulink and all. So we'll discuss one by one. And in the under the Simscape, you can integrate the multi-domain, and similarly you can develop an individual algorithm to integrate all these things. Suppose if you take a AC system, refrigerator model. So in the refrigerator model, so there will be a thermal management system and then electrical management system. So here in the Simulink, you can integrate both the model into the single work area. At the same time, you can develop a two separate control algorithm to implement the closed loop mechanism, right? And next one is that you can get a very closest accurate results for this your simulation levels. And next one, the optimization tools. So the optimization tools nothing but see, suppose if you have verified all your simulations, and now we are going to extract the simulation logic to the hardware domains. So in that case, you can optimize the logic. So whether is there any I mean unused data are there, so you can remove, you can inspect in system in code level, and then you can remove that data, so that in the hardware systems, so it won't occupy much memory, right? So that is the optimization tools. Similarly, the code generations. I will tell you with the case study how what is the code generation, how we can incorporate that code generation to the hardware systems, or not. So in the forthcoming slides. It's a level of accuracy. Fidelity is nothing but it's a level of accuracy. So under the Simscape library, first one is the MATLAB Simulink is the very basic library. Why you are not responding WhatsApp group? See, actually for login details, we have a separate team to respond the WhatsApp group. So due to that today holiday, so people will respond to you probably tomorrow or Monday. Yes. So in the under the Simulink, you have, I mean, in the Simulink, so there is a basic header files. So first one is that Simscape, and Sim Power System is the very by default library systems, and after that so sim mechatronics, and the sim hydraulics, and sim drive lines, and then sim electronics. So these are all the additional libraries which comes up with the Simscape library. By default, sim power system is the Simulink library, and in addition to that there is this four libraries. So this four library will help you to give uh, will help you to integrate all the multi-domain systems, right? So now, so let us take this is a Simulink model. So in this Simulink model, so see here one resistance is models there, and two capacitors are there. See here, if you take this example, so the same concept, the same circuit has developed in the Simscape environment. Similarly, the same concept is developed in the Simulink Sim Power System environment. All right. So see here in this Simulink, you can verify the basic logic level applications, whereas here you can verify the tolerance level or system level, very closest value to the hardware system. So let us take this MATLAB. See here in this MATLAB, see this is the voltage source, and then resistance, capacitance, two capacitance has been connected. So if you open the resistor, that is a option to vary the tolerance value. See here, suppose if you go, if you are going to purchase the resistance from your market, local market, in that case, so just to go to digikey.com. So there you can identify the tolerance values. Resistor. Yeah, just to visit this page and then get explore all these things. Resistors. Yeah, see here the support the through hole resistors. See here under this through hole resistor, there will be a tolerance values. So you can choose, yeah. See here, point not double not one, and then point not 2%, and point 1%, and 5%, 10%, 20%. See, these are all the very poor resistance value. See, this type of resistance only you are going to get it from the market. So the same equivalent value you can incorporate to the MATLAB air systems. See here, you can incorporate to the MATLAB systems. Suppose if you are going to connect one resistance to the particular value, right? So that's why we are calling this as a system level simulation models. And under the Simscape, see, this is the multi-domain case study example. So this is the mechanical systems, right? And then this is the electrical systems. And again, these are all the again, this is also drive line systems. And again, these are all the sim power system block sets. These are all the sim power system block sets. So here you can incorporate all these logics. See, under this single domain, under the single work area, so you can incorporate all these things into a single project. And we can consider all the real-time difficulties or real-time parameter changes and everything into a single simulation solution. So in that case, you can get a more accurate results than any other tools. There are a lot of tools are there to simulate your electric vehicle systems. But even though the MATLAB has a more success rate because here you can integrate everything. Suppose if you take some ANSYS tool, so there you can work, there you can generate either thermal analysis or at finite element analysis. So you cannot combine the both the thing for the accuracy level. So in that aspect, the MATLAB will give you the better solutions. Sir, what else available DigiKey? So the DigiKey is a open. Yeah, I will share you. See here you can get any type of component. So this is actually it's not an Indian site. So it's a US based site. So here you can get any kind of components that is electronic components, especially electronic components within this single source. This is the biggest source, biggest online platform for the electronic components, right? So now, how to generate a code? I mean, generate the code. So this is called the code generation model. See here, in this Simulink environment, first you have to develop a plant model, and the plant nothing but suppose if you are going to generate a single phase rectifier, so that is a plant. And for that rectifier, if you develop a PWM generator, so that is called the controller. So here, if you develop a controller, if that controller gives you the proper output, then you can convert that controller into the DLL file. So the DLL file nothing but that IPR file, intellectual property library. So that library you can generate from the MATLAB Simulink. For that one, you have to go with the license of the MATLAB. Once if you develop that particular DLL file, so that is called application code. So you can directly download that application file to the hardware systems. So that is again additional advantages. Whereas suppose if you want to develop a hardware applications, in that case you have to develop a assembly language or C language. Whereas in the MATLAB, you can no need to write any all the codes. So it will automatically convert Simulink code to the any one microcontrollers, like general microcontrollers like a microchip or TI or ST or Xilinx based processors, you can get it. So the just to check the DLL file in the Google, it's an executable file for the hardware systems. And see here, this is the plant model. So actually, this project we have already done with day 6, I think so. Just to recheck the day. And in this PFC boost converter, see here we took a source and then controller and then load model. See here, the controller is this is the only controller going to generate a PWM to the MOSFET. So in that case, if you're developing a hardware, if you are developing a hardware, so you have to convert the same Simulink file into the Simscape file. This is the plant model. So this is the plant model, and here this is the PFC controller. See, now you have to remove this model from the solutions. You have to remove from this model from the solutions, and you can take this alone. So from this file, you can convert to the you can incorporate to the any one microcontroller. So this is called application code. The same logic like a scaling or functioning, whatever it is. So you have to convert this controller into the microcontroller code. So like here the microcontroller code, inside the microcontroller there are a lot of libraries. Suppose if you want to implement a PID controller, so if you choose the hardware like a TI based hardware, in that case just open the MATLAB. So there will be a lot of libraries. Open the Simulink. I will show you how to verify that models. In our power factor correction controller, so there the gain and then PWM generator. Finally, you have to incorporate the hardware block sets, embedded system, embedded coder, embedded targets. The second, let me check the library name. I forget the library name. Yeah. See here, embedded code support package. The library name is embedded code support package. Yeah, see here. Yeah. So see here, first you have to choose any one of the processor. Under this processor, there are all the components will be here. This particular board is eligible to control your target applications. Is it clear? So this is the hardware in loop to integrate all these things. Similarly, while if it is in the running conditions, you can take a real-time parameters. Suppose if it is a load is your motor, so you can measure the speed and then current and then voltage, and you can take these parameters into the system, and then you can monitor here, and you can change the real-time parameters of these motors via this microcontroller. So that is called hardware in loop. Right. So now let us check the Simscape components. See, in the Simscape components, there are different type of domains are there, right? So as per our previous discussions, please explain this difference between Simulink and then Simscape Workbench. So please recheck the video in the initial starting class of the video where we have discussed. So please recheck it. And in the physical networks, there are two main variables. So one is called the through variable and another one is called across variable. So both the variables are different. So the through nothing but if any amount of quantity, it's flowing through that particular component. Right. Similarly, across the variable, nothing but the difference between these 2 points that is called across variable, and through nothing but if there is a quantity flow from P1 to P2. So this is called the through variable. So if you know these two variable, then you can integrate all these things into the Simscape systems. So let us take electrical systems in the electrical domain. Through variable is the current, and then across variable is the voltage. Similarly, hydraulic, in the hydraulic domain, flow rate is the through variable and then pressure is the across the variable. because pressure always needs a two different point. So in that point only you can create a pressure or you can reduce the pressure. Yes, and similarly the rotational mechanical and then translational mechanical, pneumatic, magnetic, thermal. So these are all the major variables. So you can easily understand in the electrical system. Suppose if you are an electrical engineer, the current through the wire, and similarly the voltage is the difference between the 2 points, right? Similarly, you can equate all these parameters for the various domain systems. So now we have to identify the components. See here in the domain, in the across and then as well as the through variable. So we have to calculate the equivalent values for the resistance, inductance, capacitance. So as we know, the electrical through and then across variable is the voltage as well as the current. Similarly, in the resistance, is a resistor component is used. For the inductance, inductor component. This is the energy storage devices, right? And for the capacitance, again the capacitor is used. Similarly, Similarly, for the rotational mechanical system, see actually for the rotational mechanical system, W is the rotational speed and then torque, right? So see here for that one hydraulic is the equivalent resistance parameter for the inductance parameter and then capacitance is the inertia parameter. So like that, you can integrate all the domain systems, hydraulic, translational, and then rotational, and then electrical. Similarly, you can take a thermal also. Dear participants, so please don't spam the chat. So definitely you will get attendance form. Attendance form will be provided. So please don't spam the chat. Mr. Balaji, please stop the chat. So now we can discuss how the DC motor is integrated all these things, because actually in the DC motor it's a mechanical output of the DC motor is the mechanical output, right? The input is the electrical input. So now the one device is going to convert from electrical energy into mechanical energy, right? So here for the electrical part, like in armature resistance, armature inductance, it's going to be there. Similarly, for the mechanical one, so there is a inertia, and the damper module, and other components also it's going to be there. So now how we can understand both the things. See here, resistance and the inductance are the electrical systems. Similarly, the shaft and then housing are the mechanical systems. So we have to equate all these things, right? In this one, how we can understand the DC motor. So let us take DC motor. So this DC motor has a two different component. Either in the MATLAB, so just to open the library browser. So there is a inductors as well as that capacitance you can take, and then you can model in the Simulink electrical passive components, right? Elements is see here the machine inertia and then machine mechanical power. So everything is going to be here. So by using this all these components, you can develop the you can combine with the electrical domain as well as the mechanical domain components. At the same time, default ready-made models are also there. I will show you the resistance and then capacitance. I forget the model. Yeah. So the resistor, yeah, Simscape. Yeah, like this, you can use this resistance as well as the inductances also. So you can integrate this electrical circuit as well as the mechanical circuit. Similarly, if you take a DC motor, if you take a DC motor, in this DC motor, the blue color lines denotes the electrical domain, and green color lines denotes the mechanical domain. So now you can integrate these two things, and then you can get you can use it for your applications. Suppose if you want to decode the component, go to mask and then look under mask. Right, so this is a protected one. Similarly, you can identify some of additional libraries block sets also. Yeah. See here, Simscape. Actually, this library, one of the libraries are available. I will share you the library location in via the WhatsApp group. To probably tomorrow, I will share you. If you take that one, you can modify this induct resistance of the particular motor. Suppose if you take a 5 HP motor for your available motor, because actually universally. If you take in India, 5 HP motor will give you like either maybe suppose if it is give you 4.9 HP. So in that case, the point 10 percentage loss may be in the resistive side as well as the inductive side, right? So that loss you can take into your consideration. For that, you have to remodify the library. By default you can take it, and 10 percentage error you have to include into your physical systems. So for that one, you can remodify the library. So that's why I'm just trying to show you, but I forget the name. Simply you can take this library block and then go to mask and then look under mask or edit mask. So some mask properties will be there, and here you can modify all the components. So for that one, that comes under the specialized block sets. So if you develop the particular block sets, you can publish that particular block sets into the MATLAB MathWorks central file exchange. So you can get a show, you can create your credit score in the MATLAB community, research community. So like that, you can integrate. You can change all the parameters. So for that one, you must know the basics of the complete motors as well as equivalent circuits and everything you should know. Yes. So like that, you can change the library block sets, and you can use it for your research application. You can use it for your further research applications. Rahul Tripoli, can we use PS Simulink converter between Sim power system and then other block? Yeah, of course you can use it. See here, if you want to if you want to measure this capacitance voltage across this capacitance, take a voltage sensor. So now we have to measure the voltage. Suppose if you are going to measure this one, uh, and now the display devices is the scope block, right? So the scope block is the Simulink library. Scope block, yeah, just include. So straight away you cannot connect this scope. So in between you have to connect a PS to Simulink converter. Yeah, so and after that you can connect. Like that you can do. Yes. So this is very basic introduction class about the Simulink. So please try to explore all the components. So I hope you have all the people has installed the MATLAB. So just go and then explore all the library block sets, because actually from here we are going to work only with the Simscape components, Simscape libraries for next 5 days class. So I recommend you everyone. So please just open the library block sets and then try to work it out. See here the inductor and then resistor and capacitor, everything is there. So now I will share you the reference link. You please visit this link to get more idea about it. And if you have any questions, you can ask me. If you have any questions, you can ask me. I will try to give it. What if you want to transfer data from Simulink to Simscape? You no need to do anything, Mr. Sanjay. You can integrate all the data from Simulink to Simscape. So via the PS converter, you can change the data. Yes. So thank you, participants. Thanks for your valuable time here. So tomorrow we will see in the next topic. Thank you.